Okay, we have here today an interesting integral from the MIT Integration Bee 2019, number 8. We have the integral from 0 to infinity, e to the minus 2019 over 4t squared over t squared dt. Okay, the first thing I want to notice here is just the similarity to the Gaussian integral, particularly what we have here. If we had something squared, if this was something squared right here, we have the bounds right. When you have the Gaussian integral from 0 to infinity, that's going to be square root of pi over 2. But we also have a couple problems because our exponent's different and what is going on with this t squared right here. Well, what I want to try to do is let's see if we can clean this up with a u substitution. First, I want to deal with this exponent, see if we can manipulate it into that form of the Gaussian integral. So for this, how we'll do it, let's see, if I write this, trying to write this as something squared, if I write this as first square root of 2019, if we think of that as square root of 2019 squared, and then the denominator, we can write this as 2t all squared. And then really we want this whole thing, just let's have this as one expression squared. So let's just write it like this. And then what we can try is, let's do a u substitution. I just want to substitute, I want this to be my u. That's going to clean up the numerator, and then hopefully something will work out nice here. So what we'll have is we'll say u is going to be square root 2019. Maybe I'll split it up like this, like 1 over t, just so we can see how the derivative is going to work. And then taking the derivative, so for du, what's going to happen? We'll bring the constant out front, 2019 over 2. And for 1 over t, the derivative is going to be minus 1 over t squared. Let's bring the minus out front, 1 over t squared dt. But that's not too bad because now we've got the t squared here and the dt. But before I substitute, let's try to clean it all up so the substitution comes out clean. So then first I'm going to put the exponent into this form. So let's write it as square root 2019 over 2t all squared. And then let's kind of force all this stuff in here. So actually I'm going to need to multiply in the constant. So we'll multiply in minus square root 2019 over 2. Just taking this t squared all the way out here. So we'll write it as 1 over t squared dt, just so we have all of our du stuff together. But so that I don't change it, I need to multiply by the reciprocal here. So let's multiply that reciprocal out front just so that we're multiplying by 1. And now we can go ahead with this substitution. So first let's bring down the constant in front. When we update our bounds, you plug infinity in here. What happens is now it's going to 0 with infinity in the numerator here. So we have 0 for the upper bound, plug in 0, that's going to be going to positive infinity. This whole thing here is just going to become e to the minus u squared, and we have all of our du stuff over here. I can take this minus sign, and let's use that to flip the bounds so we can get it back the way we had it here. So now we're going from 0 to infinity. But then this right here, this is exactly our Gaussian integral. So this right here is all going to have the value of just square root of pi over 2. But when we multiply this together, 2 is going to cancel with 2. I can put this all under 1 square root. So for my final solution, we just get square root of pi over 2019. Okay, there you have it. Good one today from MIT 2019. Thanks everyone for watching. Have a good day.